My name is Bryan Lowman, and as Mark told you, I am an employee of Sierra Space, formerly of Sierra Nevada Corporation. Sierra Space is a recent, now we are a subsidiary of Sierra Nevada Corporation, so I can introduce myself a little more as we go through this presentation. And let's see. All right, so I want to introduce myself before we get started here. I've got 18 years of experience in flighter operations and flight dynamics work. I started my career at NASA Johnson Space Center, working in flight operations. I supported 18 space shuttle missions, as well as numerous visiting vehicle operations to the International Space Station. About 4 years ago, I left Johnson Space Center to go work at Sierra Nevada Corporation and now Sierra Space, supporting flight operations. Why I introduced myself to you and my background is it's important. So at my time at Johnson Space Center, we used a number of in-house developed flight dynamics tools. Everything was kind of built for space shuttle, and it was very rigorous. It was just the way we flew the space shuttle. I mean, by the time I got there, we had been flying shuttle for over 20 years. So they had a pretty good idea of how to fly it. And so we basically operated it by the time I got there. When I came to work for Sierra Nevada and Sierra Space, there were some folks around who had some flight dynamics experience, and we had varying levels of familiarity with tools. Other tools that are out there, of course, FreeFlyer, as well as the STK. There's a NASA tool called GMAT, and then, of course, other folks are building their own custom software as well. So we kind of had some varying familiarity with tools that we'll eventually need to do our job when we're actually flying these missions. So Sierra Space Flight Operations, what we're trying to do here is we're currently working on the uncrewed Dream Chaser spaceplane mission. So what that involves is we have a contract with NASA to deliver cargo services to and from the International Space Station. When I started working here on this program, we identified the tools needed to plan, train, and execute Dream Chaser missions. We knew we started identifying what we needed to do, and then figuring out, all right, well, what tools are we going to do to fulfill that job? After an evaluation period of commercial flight dynamics tools, the FreeFlyer and the AI Solutions team was identified as our best path forward. And so that's how we started getting our hands on FreeFlyer and figuring out how to build what we need to do. So the way we kind of attack this problem is we identified the functions needed. So this was before we knew that we were going to be using FreeFlyer and the AI Solutions team. So looking at this big picture, there's really a lot. There's nothing unique here. I'm sure anybody who's operated or done even any analysis realizes that pretty much everything here are the types of things needed to fly and operate a spacecraft. I mean, heck, even if you've used Kerbal Spaceflight or Kerbal, the Kerbal app on your phone, these are all things that space vehicles need to do, and so this is basically what we do. So obviously, we need some unique applications here for how we are going to fly the vehicle. But once again, these are very broad capabilities that we started with. We needed to be able to highlight our launch opportunities. We needed to be able to propagate our orbit and model our attitude, plan and execute spacecraft maneuvers, perform orbit determination. Big board capability, I think we kind of saw some of those yesterday. Of course, any flight control room that you look at, any mission control, you will see a beautiful picture in the middle of the board to give everybody some situational awareness of where the spacecraft is. We need to be able to evaluate our communications, and then, of course, our real-time trajectory assessment, and then we need to figure out how we're going to get home with the orbit planning. And then, of course, we have some in-house tools that we knew we needed to interface with. So when we started having these discussions, AI Solutions sold us on three key features and functions, which is I think for those of you that were dialed in yesterday, we've seen each of these components. FreeFlyer, the engine and the core of everything here is really does all that spacecraft propagation and everything we need to be able to perform analysis. Any type of visualization. I think Michael kind of hit some of those high-level capabilities yesterday in his presentation. And really, one thing that I want to highlight that I like about FreeFlyer is I said earlier in my time at Johnson Space Center, we had these tools that were really kind of a really solid way of performing your operations, a really rigorous and fixed way that we were going to generate data and build maneuvers and plan our trajectories. What I like about one of the things I really liked about FreeFlyer is anything you can dream up, you can pretty much do some analysis on it. And right now, while we're a project that's in development, I can assess all sorts of things. Sometimes I got to reach out to the FreeFlyer tech support team to figure out exactly how to do it, but FreeFlyer really provides that capability. In addition to FreeFlyer, there's Meridian, which I think we took a nice look at yesterday as Colin was kind of walking through some of the capabilities of Meridian. What Meridian allows us to do is create these spacecraft trajectories for a Dream Chaser mission in a fixed, repeatable, and certified manner. As I mentioned, my experience at Johnson Space Center, that's kind of what Meridian does. It really standardizes our interface with FreeFlyer. We don't want our flight controllers and people making decisions and trying to script up a mission and figure out how to do things. We really need a really fixed way that we're going to perform our analysis and plan maneuvers, and so that's the purpose of Meridian. And as well as once all that data is generated, then there's a data repository for maintaining all of that flight data. And then finally, the final component is Atlas. And what Atlas allows us to do is ingest that Dream Chaser telemetry and create visualization for real-time trajectory monitoring and other type of situational awareness information. So Julie hit on some of that yesterday. So I don't want to get into everything that we can and might do with FreeFlyer because I think that's what a lot of people are involved in this conference or probably have some level of familiarity to start with. So I really want to highlight the other two items is both Meridian and Atlas and the way we're using these tools at Sierra Space. So yeah, once again, Colin presented a Meridian application yesterday, and so a lot of that core functionality we are making use of. Of course, we're taking some of our Dream Chaser specific applications and how we intend to fly our vehicle, and have created some unique tasks within Meridian here. One of which is our launch opportunities. So we have to figure out when we're going to launch and figure out where we're going to be inserted into orbit once we get into space. So we built this launch opportunity task that takes an input target spacecraft. As I said, we are currently planning a rendezvous mission to the International Space Station. So in this case, our target is the International Space Station and identifies all our available launch opportunities. So I've got a picture here of just kind of running some generic data and gives us some relevant information for each of these launch opportunities on any given day. So this is one of the functions that we've had built into Meridian. That way we're not trying to script up something on the fly, as we have a pretty fixed way in which we're computing those launch opportunities. Here's a pretty fixed task that I know Colin went into yesterday, is orbit propagation and burn planning. As we can build maneuvers into our orbit propagation, ultimately that's what we're trying to do with FreeFlyer. We're trying to understand where our spacecraft is going to be when we propagate it into the future, and try and ensure that it achieves our mission parameters. So that's what the orbit propagation is a pretty fixed way of propagating our spacecraft into the future. So here I've just got a look at what our maneuver plan looks like on a particular trajectory that we were kind of playing with one day. After we've done that orbit propagation and we can build our spacecraft trajectory, there's attitude modeling, and we can build our attitude. I know one of the things that Colin went through yesterday was, and I believe the question was asked in Meridian about a task that builds a spacecraft attitude. And I believe at least the way they were using it, they're using a MATLAB script to ingest a FreeFlyer attitude history file. We've worked with the AI solutions team to actually have a task that models how the different type of attitude holds that we use on the Dream Chaser program, and we can actually build that attitude timeline within Meridian. So we spent a lot of time with the AI solutions team figuring out how we want this task, how we want the user interface to actually build our spacecraft attitude to mimic what we're doing in space. And so you can see here, there's an attitude ephemeris, which is the output of that attitude timeline, and gives us our quaternions throughout the span of the ephemeris. So another function that Colin highlighted yesterday was the orbit product generation, and that's kind of one of the functions I'm trying to highlight here. So once we've built that trajectory that shows the spacecraft translational and rotational state, we can then run our orbit trajectory events that can generate any type of thing that really any spacecraft needs to know. We got lighting events, what our orbit count is, communication availability, object visibility, whether it be other spacecraft or ground stations. These are all things that we have interest in generating after the fact. So I just ran a quick orbit lighting events here in Meridian. So that's what I'm showing here when the sunrise and sunset is on a particular orbit I had modeled in Meridian. So that's kind of the front half of the mission, at least on the Dream Chaser program. Not all spacecraft have to figure out how they're going home. Maybe they just die in deep space. But as a on the Dream Chaser program, we need to figure out how we're getting home. So it's kind of the same thing as our launch opportunities, only in reverse. We know what our starting state is. We know which orbit we're in. Then we need to identify our landing site, and then our deorbit opportunities tool identifies all of our approximate landing times here for us to start targeting and really try and pick a real deorbit date. So this is just showing us physically when we can perform a deorbit. So starting with a particular orbit, here's your opportunities to get home. And so this is kind of the start of our planning to get home. And lastly, once we've kind of done all of this kind of mission planning, Meridian also allows us to build all our outputs to interface with our external entities. On an International Space Station mission, we have to do a lot of interfacing with the ISS team. They need to know when we're planning to show up, when we're going to be within certain range gates, and we have agreements on the data formats that we're going to share with them. And once we've have this trajectory built, Meridian allows us to export all those data formats that we have an agreement to share with NASA, and then all other entities that we have agreements with, and share that data. So that's another benefit of Meridian here. We can build that trajectory, and then we can generate the data that other folks need to do business with. And lastly, I wanted to highlight Automata. Automata is a new feature in Meridian that we're still figuring out and refining how exactly how best to use Automata. But what this is allowing us to do is it's a feature that establishes a repeatable automated process within Meridian. Right now we're still trying to at least figure out how we're going to build this plan, but we are planning to do this in an orbit for orbit determination in flight. I know once again during Colin's presentation on Meridian yesterday, he was showing a process in which they have an operational phase where they ingest measurements and process the data. Our goal here is to make that type of repeatable process. You gather the data, process the data, and output an output state. That's just something that is automated and performed every on a certain time cadence. And so, like I said, we're still working on this function with the AI solutions team. But what that allows us to do is allows this OD process to kind of go on in the background. And then once that state is ready, then we can get to our other manual phases where we're looking at our maneuver planning to try and achieve what we're trying to do, and then the orbit product generation once we have a trajectory that we're happy with based on our current orbital state. So that's kind of an overview of how we are using Meridian today at Sierra Space, and how we intend to use it once we have an operational spacecraft. I also want to highlight Atlas. Julie gave us a nice walkthrough of what we're trying to do, or what we are currently working on with Atlas. So I did want to highlight we are intending to use Atlas for real-time situational awareness by the Dream Chaser flight control team in the MCC in Louisville, Colorado. I think Julie highlighted a few of these things. We got that 2D world map right in the middle of our control room that just shows a good situational awareness display. We also have some 3D graphics that we've been looking at to kind of show us some really interesting, any items of interest, kind of show us when we're in the vicinity of ISS and what the spacecraft look like with respect to each other. And then some of the sensor field of views that we're using on the spacecraft. In addition to situational awareness, we're also using this for real-time trajectory monitoring. So we have our plan coming into the day where we have an ephemeris, and that's going to be our expectation. But based on our current telemetered state, we also are building Atlas to take that state and ensure that we are indeed on that predicted trajectory, or at least within certain bounds of that trajectory, as well as trying to build our safety corridors that we need to operate the spacecraft. So we've built a lot of that into some of our real-time Atlas displays. So in addition to the trajectory monitoring, we're also using Atlas to assess our real-time comm predictions and figure out whether or not we are going to be able to acquire our signal on our various comm assets as planned, or whether we're going to be early or late, because despite our best plans, we may not be exactly where we expected to be when we schedule our comm a day before or 2 days before, whenever that occurred. So I wanted to show you a couple of pictures of Atlas. I don't have a demo ready to go, unfortunately, but I do assure you that I know Julie had some issues in her demo yesterday. I do assure you Atlas works, and Atlas works beautifully. So I do want to show some pictures of us using it. So here's a picture of our Dream Chaser Mission Control Center, and that display right in the middle of the room is that 2D world map that you pretty much see anytime you see a picture of a mission control room. So that right there is one of our Atlas displays. And so in addition to that big board, we are indeed counting on using Atlas at our individual workstations as well. And there are a handful, namely our flight dynamics team and our communications team. They're keeping an eye on things. In this particular graphic, you can see here in the center is the 3D view. You can see the a red kind of mesh around what is the International Space Station here, and that's I think Julie highlighted it. It's part of the way we do business with ISS, and that's called the ISS Keep Out Sphere. And so in this particular view, you can maybe see a picture of a Dream Chaser that's outside, but outside of that keep out sphere. But we indeed need to make sure that we're safely outside that keep out sphere until ISS is indeed ready to receive us, and we have ensured that we are ready to enter that keep out sphere. And then it's kind of hard to see in this particular display, but there's a 2D relative motion display on the right side of that particular image. Here's a little bit cleaner view, and you can see we've got a different configuration in the middle of the board here. It's not just the 2D world map. So the display in the kind of upper left of this display is you've got your relative motion plot, but we also have our 3D views and our sensor views. And so that's the picture here in the middle of the screen shows us operating a different setup on our big board here, but it's pretty similar to the display I had shown in that previous display. And this may be a little bit, have a couple of other field of views here. You can see, once again, the ISS Keep Out Sphere on the right side, and then on the left side is a different view with the world map as well as some 3D views. So these are all simulation events that we've been running from our Colorado Control Center. And we're just kind of trying to get smarter and figure out exactly how we're using Atlas and what our best configuration is for monitoring real-time trajectory related information and how to communicate that to our flight control team. So that's pretty much how at least the tools and functions that we're using at Sierra Space today. I did want to now that we're here at the end of the presentation, I did want to go over a couple of enhancements that at least would be beneficial for us. And I think I probably communicated a handful of these things to the AI solutions team. I believe this first one is I can't remember, Michael, if this was one of the first ones that Michael touched on yesterday, but the atmospheric weather support for real-time space weather observations. Always trying to track we don't quite have our process figured out for taking in real-time atmospheric weather for drag computations within AI solutions. So having that enhancement would be much easier instead of ensuring that we're all trying to track down the right files to use. Another ability here, and that might this just might be something that we need to figure out a better way to use some of the currently built-in tools in FreeFlyer, is the ability to pause a code in run and determine values of all the variables in the mission plan. I think we can probably put some of that in data tables, but I think somebody on our team was mentioning to me it's a function that's pretty useful within MATLAB. And so I think the recommendation for our team is that would really be able to help us in debugging our mission plans that we're building for our particular uses at Sierra Space. Another thing that was discussed yesterday was those blockage diagrams, particularly when you're talking about sensors or antennas and where those 2D blockage diagrams would come from. That is something that is done at Johnson Space Center, and of course, we have some of that experience on our team, and we have familiarity with those. So being able to generate blockage diagrams would be really beneficial. And I do know, lastly, I do know FreeFlyer has the capability of using a SPICE ephemeris, but that is something that some of our in-house tools use as well. And sometimes when we're trying to troubleshoot propagation in one tool versus the other, making sure our propagation models and our perturbation models are in alignment with each other is really, really beneficial. And just using an inherent SPICE ephemeris format in the BPC file format would be really beneficial.
One question from the audience is, you mentioned your experience in operations for the shuttle and the ISS. How do the operations that you're building out with Meridian compare to the workflows that you experienced on the shuttle and ISS programs?
That's a good question, and I attempted to highlight it in there, but what like I said, when I got to work in the shuttle mission, they had a very defined process for how we're going to operate the vehicle, and you have these very rigorous ways that you're generating burns and you're generating orbits. We're seeking to do that with this tool suite here. We're really trying to recreate some of the experience that I and the rest of our Sierra Space team has had from all over. But myself, coming from the flight operations for Dream Chaser, what I'm kind of helping to lead that effort, and so we're really trying to replicate a lot of that really fixed interface and how we're doing those things in a very fixed and certified manner of generating this data. So we're trying to really create a lot of that from the Johnson Space Center experience.